Okay, for chemistry homework. Chemistry day one homework, it was just reading the book. I don't think I need to go over that just now, but what I am going to do is go over the homework from day two. So this was molality and molarity, because I think there was some confusion here. So for the homework, we had to do the section review, 1 through 6, right? So question 1, how is solubility related to concentration? So how they're related is that concentration is literally a measure of solubility. They're that closely related. So the reasoning is because the higher or lower concentration is completely deciding how soluble something is. If you have way more solute than solvent, right, because it's solute over solvent in your concentration, your solubility is going down. Because the more solute you have in your solvent, the less soluble it's going to be. That's how they're related. Number 2. List 2 different units used to express quantities of a solute in the different measures of concentration. Really complicated way to say, what are the units in your solute? So let's look. Solute. I see moles of solute. Um, I see volume of solute. I see mass of solute. Moles of solute. So really the most common ones are going to end up being, getting my page back together, grams and moles. Percent by volume. I mean, you could also technically say liters. So I'll say all three. Grams and moles and liters. If you only pick two of those, I'm fine with that. Question number 3. What volume units are used in calculating percent by mass? This was a really silly trick question. If you look at your volume percent by mass, it's all kilograms and moles. You don't use volume. So, none. Slayer. Um, grams are used to measure mass, not volume. Oops. Trick question. Question number 4. What is the most common measure of concentration in scientific studies, and what is the least common? So this was actually directly in the text for each section. So if you read through it, then you would have found this. But basically, the most common is molarity. You'll use that a lot in college chemistry. And percent by mass is the least. I want to say that in my college lab studies, we used percent by mass one day of the entire semester, and we used molarity most of the time. So that is not wrong. 5 and 6, these were the tricky ones. These were the ones that I know. So I just tried explaining number 5, and I made some pretty hilariously bad explanations. So let me do this one more time and make it clear. So, what mass of K2SO4, right there, what mass of K2SO4? We're looking for the mass of K2SO4. And since we know that, we can go ahead and use the periodic table to find the weight of this, because we are going to use that eventually. And I'll go ahead and write it here. It's going to eventually be 174.27 grams. If we add together 2 potassiums, a sulfur, and 4 oxygens, that's what we get. So we'll use that for later. What mass are we looking for when the problem gives us that we have 550 milliliters and a 0.76 molar solution? What's the equation for molar? It's moles per liter, right? So what is this saying? We have 0.76 moles for every liter. Moles per liter, okay? Moles per liter. So if our molar equation is telling us that we have 0.76 moles for every liter, and we're going to eventually need the mass of K2SO4, then let's go ahead and find out how many moles of K2SO4 we have. So this is literally just stoichiometry. Don't get intimidated by it. We have liters. We're looking for the mass. How is mass measured in grams? What is usually the middleman? Moles. We're doing the exact same thing that we did before we left. So liters, where did we start? They give us 550 milliliters. Okay? Milliliters is not liters. So if I convert to liters, how many milliliters are in a liter? 1,000. Your milliliters cancel. So what did my equation say? How many liters do I how many moles do I have for every liter? 0.76. Cool. And this would be moles of K2SO4 because that's what the solution is. Cool. If you're lost here, you probably need to review the example problems in this chapter. So please, if you're lost here, please review those problems. They might help clear things up. But to explain the process, they asked us, what's the mass? Well, I don't know, but I know that if I'm looking for the mass, I'm going to end up wanting to get to grams from somewhere, right? And then I said, okay, if I want to get to grams, what's usually the process? Well, to get anything into anything in this class, we have to go to moles first. Okay? So do they give me moles? Well, they give me moles per liter, but that's not specifically for K2SO4. So I can't jump straight from moles to grams because they actually tell me how much I have. 550 milliliters. So I need to start with liters. So I know where I'm getting to, and I'm working my way back each piece of the way. So here, I took the liters, I turned them into liters, and then I went from liters to moles. So right now I'm at this step. So I have 0.76 moles. What happens when I multiply 550 times 0.76 and then divide it by 1,000? For this, I did end up with 0.42 moles of K2SO4. So now that I have moles, I'm going to move to grams. I'm going to start with 0.42 moles of K2SO4. How do I go from moles to grams? Well, I'm going to have a G up here somewhere. In the denominator, I got to have 1 mole. So how many grams are in 1 mole of K2SO4? I looked at the periodic table and I found my number. 174.27 grams of K2SO4 over 1 mole of K2SO4. The moles of K2SO4 cancel out, and turns out if you multiply 0.42 by 174.27, you end up with 73 grams of K2SO4. That's the mass of K2SO4. This was a hard problem. If you did not get it, I don't blame you. Recommendation again, please look at these example problems, and if you need to, look back at the chapter about stoichiometry. Because unfortunately, at some point this week, we're going to end up having a quiz, and I'm going to put a problem like this one on there, so make sure to study it. That's just a little tidbit. So number 6. A radiator is filled with a mixture of 3.25 kilograms of ethylene glycol, which is C2H6O2, and they put that all inside 7.75 kilograms of water. Calculate the molality. So what's the molal equation? Little m equals moles of solute over kilograms of solvent. Which one's going to be the solute and which one's going to be the solvent? Now I told you that really you can usually tell because the solvent, there's usually a lot more of it. So which one has more? 7.72. So that one's going to be in the denominator. So my equation is going to have 7.75 kilograms of H2O in the denominator. And guess what? Kilograms, that's the correct form. Now what's supposed to be in the numerator? 3.25 kilograms of, what is it? Ethylene glycol. Is that in the right form? No, I need to be in moles, and it's in kilograms. So how do I get from kilograms to moles? Well, I can't be in kilograms. I need to be in grams. and I know how to go from grams to moles. So it looks like this is going to be my process. So I'm starting off with 3.25 kilograms of C2H6O2. And I need to get from kilograms to grams. So for every kilogram, how many grams do I have? 1,000 grams. Okay? So now I am in grams. Hooray! How do I get from grams to moles? Well, I want to be in moles, so I'm going to put that in the top. 1 mole of C2H6O2. What is the molar mass of C2H6O2? If you go to the periodic table and add all these janky numbers up, you do end up with 62.07 grams. So what you end up with, grams. So what you end up with is 3.25 times 1,000 divided by 62.07. And when you, I'm sorry, you couldn't see any of that. Oh no. I hope that's okay. I started with kilograms. How many grams are in a kilogram? 1,000. So I went to grams, and now I need to go from grams to moles. So I go to 1 mole. How many grams of this exist? I went to the periodic table and I added the numbers up and I got 62.07. When you summarize all this and you put it into a calculator, you end up with 52.4 moles of C2H6O2. And guess what? Now I'm in moles, so I can put that number in here. 52.4 moles of C2H6O2. And I'm looking for the molality. So if I just do this division, I end up with 6.76 molal. And that's my answer. If you need me to go deep into depth with this, I would be happy to. And work some more examples. If you'd like me to do that, send me a direct message on GroupMe, and I'll consider taking a day to really focusing on these types of problems. But other than that, there's your answers. Have a great day. Hello, students. So for day 1 and 2, I'm going to go over the homework from those 2 days and explain things to you if you still don't get it, okay? If you understood the homework and you're good, then you don't have to watch this video, but I'd recommend you watch it. Anyway, just know that it's not required. So for day 1, I gave you 3 linear functions, and I asked you to make a t-table and then graph them. So number 1 was y equals x plus 3. Great. So I'm going to make my t-table right over here. Cool. This middle point right here, I told you is going to come from really your y-intercept, and your k value on these tells you your y-intercept. So if my y is 3, then my x is 0, because it's a y-intercept. So from my starting x value, I go 2 up and then 2 down. So my 2 up would be 0, 1, 2, and my 2 down would be 0, -1, -2. Then I proceed to plug these numbers in for my x in the equation to get my new numbers. So what's y equals 1 plus 3? 4. What's y equals 2 plus 3? 5. What's y equals -1 plus 3? 2. And what's y equals -2 plus 3? 1. So these are my 5 points, and now I graph them. Remember, x is left and right, y is up and down. So if I go left 2, up 1, there's my point. If I go left 1, up 2, there's my point. If I go 0 left or right, and then 3 up, there's my y-intercept. If I go over 1, up 4, there's my point. And if I go over 2, up 5, there's my point. And if I now trace the line that I got, this is a linear function because the x is the power of 1, so this makes sense that I have a line, and it looks good to me. It doesn't look uneven. So really, this line just got shifted up by 3 because the y-intercept was 3. And because k is the vertical shift factor, remember? So since my k is 3, because this equation is really y equals ax plus k. That k is a vertical shift, so it shifted the whole line up 3. Number 2, y equals negative 1 half x. 1, 2, 3, 4. Okay, so what is my starting point going to be? Do I have a k value? No. That means I get to start at 0, 0, which I'm a fan of. I go up 2 from my x value here, 1, 2, down 2, negative 1, negative 2, and then I plug in each one of my numbers. What's negative 1 half times negative 2? Well, the negative 2 times the negative 1 gives me positive 2 over 2, and positive 2 over 2 gives me 1. What is negative 1 times negative 1 half? Well, 1 times anything is itself. The negatives are going to cancel out, so I'll end up with 1 half. What's 1 times negative 1 half? Well, 1 times anything is itself, so it's negative 1 half. And what's negative 1 half times 2? Well, it would be the same thing as this, but just without the negative. So instead of positive 1, we're going to end up with negative 1. So we have half, so that's going to be annoying to graph, but oh well. Negative 2, so that's left 2, and then up 1. I have left 1, and then up 1 half, so I'm just going to go halfway up this little line. 0, 0. Right 1, down a half, so I'm going to go halfway down. And then right 2, down 1. Which it looks like a line. It's a linear function. So I can look at this and say, does this look how it's supposed to look? Well, number 1, did my negative flip the shape like it was supposed to? Yes. Instead of going up, it's going down. Great. Did the 1 half, did that vertically compress it, make it squished? Yes, this one looks taller than this one, so I did it right. Number 3, y equals 3x plus 1. Okay, I have a y-intercept here. So at 1 for y, my x will be 0. I'm starting at 0, so I'll go up 2 and then down 2. I have a 3 times, so if a 1 half makes it compressed, the 3 is probably going to stretch it. So already I'm looking for it to be not this, but this. It's going to look really steep. So I'll plug in my numbers. What's 3 times negative 2 plus 1? 3 times negative 2 is negative 6 plus 1. That gives me negative 5. Negative 1 times 3 is negative 3. Negative 3 plus 1 is negative 2. Positive 1 times 3 is 3, plus 1 is 4. Positive 2 times 3 is 6. 6 plus 1 is 7. So I have my 5 points. They're a little bigger than normal, so I go left 2, down 5, left 1, down 2, stay left and right here, but go up 1, go over 1 and then up 4, 1, 2, 3, 4, go over 2 and then up 7, 1, 2, 3, 4, 5, 6, 7, ooh, right at the top. So if I trace a line through all my points, oh, I'm going to get into my handwriting up there. Does this look how it's supposed to? Well, this is looking like this angle, and it looks like this one is at this angle. That's a lot steeper, so it looks like I did that right. Hooray! That was the homework from day 1. Oh, oops. No, we're supposed to list our transformations. So, my bad. This was just plus 3. The k is a vertical stretch. No, I'm sorry, it's a vertical shift. So I had a vertical shift, and it looks like it went up 3. For the second one, it didn't shift anywhere, so it didn't move anywhere, but I did have a squish factor, right? It did get compressed. So I had a vertical compression, by a factor of 1/2, and also that negative flipped, right? So I also had it reflected Oof, over the x-axis. So I had 2 for that one. For number 3, I had a vertical shift up 1, and it looks like I also had a vertical stretch by a factor of 3. Great. So, homework from day 2. So, these were quadratics, which means they were supposed to create that parabola shape. So let's see if we can get that. So, oh, dropped my pen. So let's create that XYT table. I've got some bleeding, but that's fine. 1, 2, 3, 4. Okay. So for this one, remember, I'm looking for my h and my k. That equation, the y equals a x minus h plus k. I'm looking for these to tell me the vertex, right? The opposite of h and k. So do I have an h inside parentheses in this problem? No. So my h is going to be 0. Do I have a k? Yes, I do. It's a 3. That's where I'm starting. So I'm going to go up 2 from 0, and I'm going to go down 2 from 0. Now I just plug the numbers in. What's negative 2 squared? 4. Plus 3? 7. What's negative 1 squared? 1. What's 1 plus 3? 4. What's 1 squared? 1. Plus 3? 4. What's 2 squared? 4. Plus 3? 7. So now I graph these 5 points. So left 2, up 7. 1, 2, 3, 4, 5, 6, 7. Whoa. Very top. Left 1, up 4. 0, 3. 1, 4. And then 2, 7. Like I said in the lesson, these are usually symmetrical, so once you know half of them, you can kind of just draw the rest of them. So I go up this way, and I go up this way. Great. What transformations did I have? Well, I had a vertical shift, right, just like the last problems, up 3. And that was it. No other numbers. Second problem. Y equals negative quantity of x plus 1 squared minus 1. A little more complicated. So, XYT table. Oh, that hole's in the way. 1, 2, 3, 4. What's my vertex going to be? Remember, it's the opposite of h and k. So my h is plus 1, so I'm going to write negative 1. My k is negative 1, so I'll write negative 1. I go up 2 from here. So up 2 from negative 1 would be 0 and then 1. And down 2 from negative 1 would be negative 2, negative 3. Now I plug in my numbers, as annoying as this will be. So I have, I'm going to do this on a separate piece of paper because I don't have enough room. Let's use this sucker. Okay, so I have y equals negative 3 plus 1 squared minus 1. Negative 3 plus 1, this is negative 2, so I have negative 2 squared minus 1. What's negative 2 squared? Positive 4 minus 1. So that gives me negative 4 minus 1, and that gives me negative 5 when I combine them. So my first point is negative 5. Now what happens if I plug in a negative 2 here? Y equals negative quantity of negative 2 plus 1 squared minus 1. So I simplify this to negative 2 plus 1 is negative 1. So I have the negative quantity of negative 1 squared minus 1, all the ones. Negative 1 squared is positive 1, so I have negative quantity of positive 1 minus 1. That's negative 1 minus 1, negative 1 minus 1. Those are two negatives combined, so I get negative 2. Since this is symmetrical, I should have the same numbers on this side that I do this side, so I'm just going to copy them over, negative 2 and negative 5. That's the advantage of having the vertex. So Graphing, my vertex is left 1, down 1. So this is where the center of my graph will be. If I go 1 this way, it's left 2, down 2. So 1, 2, 1, 2. If I do this side, I'll have stay at 0, but then go down 2. For this final point, I'll have left 3, down 5. 1, 2, 3. 1, 2, 3, 4, 5. And then for this point, I'll go over 1, down 5. So does this make sense? Well, the vertex has changed, so that makes sense. What should that negative do? The negative reflects it over the x-axis. Does this look upside down? Very much so. So it looks like I did it right. So what are my transformations here? I'm going to have to write them up here. Actually, I don't have any room to write them. Uh-oh. Maybe I should have given you guys better graphs. Hindsight's 2020. The negative, I have a reflection over the x-axis. This horizontal shift, right? You change the sign, so I'm not going right 1, I'm going left 1. So I have a horizontal shift, left 1. And then this is a vertical shift, down 1. Great. And that explains the whole thing. Third problem, y equals 3x squared minus 2. We got some shenanigans here. Let's get my xy table online. What's my vertex going to be? Do I have an h value? No, so it's 0. What's my k value? Negative 2, negative 2. I go up 2 from 0, down 2 from 0. Fantastic. So now it looks like I'm just going to plug my numbers in. So let's do it on the separate piece of paper again. So if I plug in negative 2, I'd get 3 to the quantity of negative 2 squared minus 2. Negative 2 squared is 4. So I have 3 times 4 minus 2. 4 times 3 is 12. Minus 2 is 10. Great. If I plug in a negative 1 there, 3 times the quantity of negative 1 squared minus 2. Negative 1 squared is positive 1. 3 times 1 minus 2. 3 times 1 is 3. Minus 2 is 1. Parabolas are symmetrical, so I can just copy the next numbers right here. Now I graph them. Left 2, up 10. 1, 2, 3, 4, 5, 6, 7. I don't have any room, so I'm just going to throw it up here. Left 1, up 1. Stay in the same place and go down 2. Go over 1 and then up 1. Go over 2 and then up 10. Somewhere up here. Well, this is certainly an interesting shape, isn't it? Great. Does it follow the rules? What did that negative 2 say? This negative 2 said we would have a vertical shift down 2. Well, the vertex is down 2, so that checks out. What does this 3 do? It's a vertical stretch factor, right? Because it's bigger than 1. It's not a fraction. So we also had a vertical stretch by a factor of 3. Would you say that this is about 3 times as tall as a normal graph? Probably. Look at that. Big difference. Big difference. Cool. Last problem. Y equals 1/2 times the quantity of x minus 3 squared plus 1. This one's a doozy, isn't it? So, let's do the xyt table. So what is our vertex going to be? The opposite of h, so positive 3, and you keep k. Then I go up 2 on my x's, so 3, 4, 5. Then I go down 2, 3, 2, 1. These are my x values. So what happens if I plug in a 1? Looks like I end up with y equals 1/2 times the quantity of 1 minus 3 squared plus 1. If I simplify this, I end up with 1/2 times the quantity 1 minus 3 is negative 2 squared plus 1. Negative 2 squared is positive 4 plus 1. 4 divided by 2, oh, that's not on the screen. 4 divided by 2 is 2, so I end up with 2 plus 1, and that's 3. One more. Let's plug in positive 2. Y equals 1/2 times the quantity of 2 minus 3 squared plus 1. 2 minus 3 is negative 1 squared plus 1. Negative 1 squared is just plain old 1. 1/2 times 1, surprise, is 1/2 plus 1. I end up with, you can write it as 1.5 or 1.5. Cool. I'm going to write 1.5 to save space. This is symmetrical, so I can just copy the numbers around. So let's graph these suckers. Right 1 up 3. Right 2 up 1.5. So I'm going to go right 2 up 1.5. Right 3 and then up 1. 1, 2, 3, 1. Right 4 and then up 1, 1.5. 1, 2, 3, 4, up 1.5. And then right 5 and then up 3. 1, 2, 3, 4, 5, 1, 2, 3. Cool. I have a very squished parabola. Now, is that what it's supposed to look like? Is it supposed to look half as tall as your other parabolas? Well, yes it is. Hooray. So, what are my transformations here? Well, that 1/2 is causing a vertical compression by a factor of 1/2. This is the disadvantage of using markers, guys. You don't have enough room to write stuff. What's that negative 3 saying? That's our h, and if we take the opposite, it's plus 3. So that's a horizontal shape. I'm sorry, a horizontal shift. And it's minus 3, so that would be right 3. Then we have a plus 1, and that would be a vertical shift up 1. So there you go. These are the answers to your homework. Hopefully you used a pen or a pencil so it would fit better. But I hope you understood these, and I hope that if you didn't, this helps clarify a little bit as to where you went wrong. Bye.